Hello everyone! Today I wanted to show you how to make a file downloader application using Python. So we're going to start from the basic, which is to download a small file and save everything from the internet to our local file system all at once. Then we'll move on to download large files, and we'll also be adding the ability to resume download to our application so that if we close the program or any network interruptions happened before the download finishes, the next time we open the application, it will resume the download right from where we left off. We'll also be adding a progress bar and file integrity check using MD5 or SHA-256 checksum to make sure the downloaded file is the same as the original file. So it's a small program, but there are a lot of details to cover, so let's jump right into it. Now, create a new project folder and open it up in VS Code or any other IDEs that you prefer, and let's create a new Python virtual environment for this project. So let's type py-mvenv.venv and hit enter. All right, now let's activate our virtual environment. So let's do .venv /scripts/activate. All right. Now, in order to download files from the internet, we're basically sending a network request to the server which the file is located on, and then save the response data into a new file on our local machine. And that's the file we wanted. So we need to use the request library to help us do that. So let's install it first of all. So let's type pip install request and hit enter. All right, now let's write our program. Create a new file called file downloader.py. And for this video, I'm gonna download the Python installer as a demonstration. And I'll be put the link in the description for anyone who wants to follow along. And let's head over to their website. So this is the Python download page, and let's scroll down. There's a file list. I'm gonna be using the Windows installer 64-bit. So let's right click on it and click on copy link address. And let's go back to our IDE. All right, let's create a variable called download link and paste in the download address. All right, now let's define where we want to save the downloaded file on our local machine. So I'm just gonna save it in my current working directory. So to do that, let's import OS first of all. So import OS, and then let's define the saved file name. File name equals, I'm just gonna name it Python installer .exe. All right, and then the save path should be os.path.join. So I want to join the current working directory. So os.get current working directory. Join the current working directory with our file name. So like this. And then let's actually print the save path, make sure that it's the directory that we want. So print save path, save it. And let's run this program. So py file downloader.py. All right, so as you can see, this is the current working directory to my program. So now let's remove this line. And let's now do the download part. So let's write a try and except block. So except exception as E. I'm just gonna print out the exception. So print E. All right, now let's import request library. Requests. And then let's send the request to our download link. So with request.get, it is a get request to download the link as R. And then we need to save the response content into the save path with our file name, right? So what we can do is we need to first of all open the save path file. So with open save path, and the mode should be write binary, all right, as F, and then we do F dot write R dot content. All right. Now, that's basically everything you need to download files from the internet. And let's actually run this to make sure that we can get this file and save to our local system. So let's run the program again and wait a couple seconds. All right, as you can see, the Python installer.exe is here in my working directory. So that means our program works well so far. So now I wanted to make sure that the file we saved is the same as the one on the server. So I was downloading the 64-bit Windows installer, and I'm just going to copy this MD5 sum and go back to our VS Code and see if the file on our system, the MD5, matches the one on the server. So in VS Code, let's define a variable called official MD5 equals and paste in the value. And then we need to calculate the MD5 of our local file. So to do that, let's import hashlib. And then let's define a new method to calculate the file MD5. So def MD5, it takes a parameter. I'm just gonna call it file path. All right, and then initialize the MD5. So hash MD5 equals hashlib.md5. All right, let's open a file for calculation. So with open file path, and the mode should be read binary as F. Okay, so in order to calculate a file MD5, we don't want to read the whole file into memory, and that's going to be very slow for a hash function. So what we want to do is to read the file chunk by chunk and then update the MD5 chunk by chunk. All right, so to do that, let's write a for loop with a lambda function. So for chunk in iter lambda f dot read. I want to read 4 kilobytes per chunk. So like this, and then let's update the hash md5 dot update chunk. All right, so after all of that, let's return hash md5 dot hex digest. All right. Now this is how we calculate a file's MD5. Okay, now let's compare this to the official MD5. So download MD5, downloaded MD5 equals calling the function that we just created, save path, and then let's compare. So if official MD5 equals downloaded MD5, let's print MD5 matches download success. All right. Else, let's print download fail. All right. Now let's actually delete this and then run the program again and see if we got the correct file. All right, now it says MD5 matches download success. That means our program works. Okay, so now let's try to download a larger file. And for that, I will be using a Alpine Linux ISO file. So let's head over to their website and copy the download link. So this is the Alpine Linux official website. And then scroll down. We're gonna be using the standard and the 64-bit version, and then let's right click on it and copy link address. And also we need to verify the SHA-256 checksum. So let's left click on it and save the file. All right, let's go back to our IDE and let's paste in the download link. So let's replace this. And then replace the file name with Alpine Linux.iso. And then save path is the same. And for the checksum, this time it's using SHA-256. So let's copy this value. This is the file we just downloaded. All right, and let's copy this value and go back to our program, and let's actually just comment this out and make a new official SHA-256 equals. All right, now let's define, it's the same as MD5. Let's define a new method called SHA-256 and takes in the file path. All right, we can just actually copy this. So copy and paste it here and change these MD5 to SHA-256. All right, and change this to SHA-256. And then with open file path, write binary as F for chunk, read 4 kilobytes. And then we have hash SHA-256 dot update chunk, and then hash SHA-256 dot hex digest. All right, so it's basically the same function as calculating MD5. It's just change all the MD5 to SHA-256. Now, as for the download part, whenever we're processing large files, we don't want to read everything into memory all at once. For our GET request, what we want is a response stream so we can split it and save it chunk by chunk. So in our GET request, let's add a new argument. So let's call it stream is true. And then whenever we save the file, we don't want to save the whole content. We want to save it chunk by chunk. So let's write a for loop for chunk in r dot iter content, and then let's define the chunk size. I want to read 10 megabytes per iteration, so it's 10 times 1024 times 1024. All right, and then let's write not our .content, but we just write each chunk. And then we need to change this to from write binary to append binary. So every time we open the file, we want to append the current chunk to the previous file. All right. And then I also wanted to show how large the file is. So let's define a total size equals, we can get this, the total file size from our response header. So let's do r.headers.get. So the attribute name is content length. All right, let's wrap it in an integer. I want an integer, so yeah. All right, let's print. So print total download file size is bytes in the format total size. All right, and then that's the download part. And then for the checksum verification, we don't have download MD5. What we have is downloaded SHA-256 equals SHA-256 save path. And then let's change this to official SHA compared to downloaded SHA, and print SHA-256 matches download success. All right, let's save this and let's run this program. Let's clear the screen and run this program. Let's run this, and this time it's gonna take longer because the file is larger than the Python installer, so let's give it some time. All right, so the program finishes and the total download file size is about 250 megabytes, and the SHA-256 matches download success. That means our program works as expected. So now I wanted to add a progress bar to our program. So a good library to do that is tqdm. So let's install it. Pip install tqdm. All right, and let's import it. So from dm import tqdm. And then down to where we download the file, let's initialize tqdm. So t equals tqdm, and take some arguments. The first one is total equals total size, and then unit is I uppercase B, and then we want to scale the units, is unit scale is true. And then we also wanted to leave equals false. That means don't leave any trace after the program finishes. So with that, when we write the file chunk by chunk, we also wanted to update the progress bar chunk by chunk. So t dot update the length of the chunk. All right, let's save it and let's run this time, see if we got a nice progress bar. So let's clear the screen first, and then let's remove this ISO file we downloaded last time, and then let's run this program. Let's see if we got a progress bar. Okay, now as you can see, the progress bar is running, and on the left hand side you can see the percentage, and the right hand side you can see the total file size, expected finish time, and the network speed, which is pretty cool. So let's wait for it to finish. All right, now as you can see, we have the progress bar completed 100%, and the file is downloaded. Now, the last step before we finish our application is to be able to resume the download if we quit the program before the download finishes. To achieve that, there are 3 things we need to change to our program. First, we need to check if the file already partially existed on our local file system. Second thing is, if the file existed, we need to make the request library to return the response from the very next byte of our partial file. For example, our partial file is 100 bytes large right now. And to be able to resume the download, we need 101 byte to append to the current partial file. So we need to tell the request library to basically ignore the first 100 bytes and give me the response starting from the 101 byte. And the third thing is, of course, we need to change our progress bar to resume from the correct percentage. Okay, so let's do all of that and complete our application. So to check file existence, let's import the path library. So from pathlib import path. And then down in the try block, before we making the request, let's do, so if path save path dot exists, and then we need to define a initial position. So init position equals path save path dot stat dot st size. So this is the file size of the current partial file, and basically is the init position of our GET request. So in order to tell the GET request to use this init position, we need to pass it in the request header, and we need to use the range attribute in the request header. So let's define a resume request header equals, so range is the attribute name, and the value should be bytes equals from the init position to the end. So dot format init position, and then else if the file doesn't exist, init position should be just 0, and then resume request header equals range bytes equals just 0 to the end. To use that in a GET request, let's set the header argument to our resume request header. And then since we are requesting only from the next byte of our partial file, the content length will only give us the rest of the file size. So we need to add the init position to get the actual total file size. All right, and then print is okay. So to update the progress bar, we need to add a new argument, which is called initial is init position. All right, so that will let the progress bar to resume from the last correct percentage. And then with open save path, we want to append binary, of course, and the rest are basically the same. So we can actually test this now. So let's remove the previous download results, and then let's clear the screen. Let's run the program. And this time I'm gonna stop the program halfway, and then I'm gonna resume it and see if the file will be downloaded and appended to the correct file. All right, so let's run it and let it run for a couple seconds. All right, so 12%, 17%. All right, I'm gonna cut that. And then let's see. So it's like 21%. All right, it downloaded 21%. And let's restart it. It's supposed to resume from the 21st%. All right, let's run it. All right, it seems pretty good for now. All right, and the total file size is about 250 megabytes. It's the same number. All right, let's see if the SHA-256 matches. All right. All right, so SHA-256 matches, download success. So that's how we do resumable download in Python. And that's basically everything we wanted to talk about in this video. And we have talked about a lot of things. All right, download simple files, download large files, verify checksums, and we add a progress bar. And we also do resumable download. So hope you guys learned something, and thanks for watching. I'll see you in the next video.